students, welcome to our Grade 8 Mathematics Student Support Program. We are doing a series of videos on some topics where we think you have difficulties. This would help you for your revision. So the second topic is going to be LCM of algebraic terms and algebraic fractions. So let us start. So we consider the first example. Find the LCM of 12 and 18. Again, we are going to have two methods just like for HCF. So the first method is using prime factorization. So 12 can be written as 2 times 2 times 3. 18 can be written as 2 times 3 times 3. So here we need to be careful. 2 is common and 3 is common. For the LCM, I'm going to take the common factors only once. So here I'm going to take only 1, 2 times 2. Here I take only 1, 3 times 3. I don't write 2 twice. I don't write 3 twice. I take it only once. So I have 2 times 2 times 3 times 3, which gives me 36. Now, I need to find the LCM of 12 and 18 again, but this time we're going to use the index form method. So 12 can be written as 2 to the power of 2 times 3 to the power of 1. 18 can be written as 2 to the power of 1 times 3 to the power of 2. So here the highest power of 2 is 2 and the highest power of 3 is 2. So the LCM is going to be 2 to the power of 2 times 3 to the power of 2, which gives me 36. For this method, I'm going to consider the highest power. Now we move on to LCM of algebraic terms. The first example. Find the LCM of x y square and x square y. We're going to use the first method, that is expanded form. So xy square can be written as x times y times y. X square y can be written as x times x times y. So the LCM here will be x, which I'm going to take only once, times x, times y, here I take it only once, times y, which gives us x square, y square. So the LCM is x square, y square. Next example, find the LCM of pq square and p cube q cube. We use the method of expanded form. So pq square can be written as p times q times q. P cube q cube can be written as p times p times p times q times q times q. So here p is common, q is common 2 times. So the LCM is going to be p times p times p times q times q times q, which gives me p to the power of 3, q to the power of 3. Next example, find the LCM of a square b c cube and a cube b square c. So here we use the method of index form. A square b c cube can be written as a square times b to the power of 1 times c to the power of 3. A cube b square c can be written as a to the power of 3 times b to the power of 2 times c to the power of 1. So here the highest power for a will be 3, the highest power for b will be 2, and the highest power for c will be 3. So the LCM is a power 3 times b power 2 times c power 3, which gives us a cube b squared c cubed. As you can see, we have considered the highest power of a, which is 3. The highest power of b is 2, and the highest power of c is 3. So here are some exercises for you to practice on LCM of algebraic terms. We now move on to algebraic fraction. So what is an algebraic fraction? Algebraic fractions are fractions which contain algebraic terms either in the numerator or in the denominator or in both. Some examples of algebraic fractions are 7a over 8. So here we have an algebraic term in the numerator. 2 over p. Here the algebraic term is in the denominator. We then have 2xy over 5z, where the algebraic terms are in both numerator and denominator. One last example is 2 over 7 into m minus 4. So these are some examples of algebraic fractions. Now, let us see how we can simplify algebraic fractions. An algebraic fraction can be reduced to its lowest term. Let us consider some examples. So the first one, 2a over 4a, and the second one, 6xy over 15y. So how can we simplify the first one, 2a over 4a? If I write it in expanded form, I will have 2 times a over 2 times 2 times a. 4 can be written as 2 times 2. So you can see that 2 will cancel with 2, a will cancel with a. So in the numerator, I have 1, and in the denominator, I have 2, which is left. So 2a over 4a can be simplified and written as 1 over 2. Now 6xy over 15y can be written as 2 times 3 times x times y over 3 times 5 times y. So 3 will cancel out and y also will cancel. So in the numerator, I'm left with 2 times x, which is 2x, and in the denominator, I have 5. So 6xy over 15y can be simplified as 2x over 5. A third example, 20p square q cube over 36p cube q square. If I write it in expanded form, I'll have 20 can be written as 2 times 2 times 5. And then I have p square p times p. Q cube, which is q times q times q. 36 I can write as 2 times 2 times 3 times 3. P cube is written as p times p times p. Q square is written as q times q. So 2 will cancel out. Again, 2 cancels out. Then I have p, which will cancel out. Again, p. And then q will cancel out. Q again. So in the numerator, I'm left with 5 times q, which is 5q. And in the denominator, I have 3 times 3 times p, which is 9p. So the answer is 5q over 9p. We now move on to addition or subtraction of algebraic fractions. We are going to consider 2 different types. Case 1 will be dealing with algebraic numerators, and case 2 will deal with algebraic denominators. So first one, algebraic numerators. Part A, 2a over 9 plus 5a over 9. So here it is quite simple. I have the same denominator. Both have denominator 9. So the common denominator is 9, and I just need to add 2a to 5a. which gives me 7a over 9. Part B, 3a over 7 plus a over 4. So here we have two different denominators, 7 and 4. Just like we do for additional subtraction of fractions with different denominators, I need to find the LCM to express both denominators in terms of a common one. So the LCM of 7 and 4 is 28. Now, 28 divided by 7 gives me 4. 4 times 3a, the numerator of the first term, plus 28 divided by 4, which is 7, times the numerator of the second term, which is a. This gives me 4 times 3a, 12a, plus 7 times a, 7a. Now these two are like terms, so I can add them. 12a plus 7a, which gives me 19a over 28. Part C, 5y over 8 minus 3y over 5. So the LCM of 8 and 5 will be 40. Now 40 divided by 8 is 5. So 5 times the numerator of the first term, that is 5y, minus 40 divided by 5, 8. 8 times the numerator of the second term, that is 3y. Simplifying will give me 5 times 5y, 25y. 8 times 3y, 24y. And between these two, I have a minus sign. The whole of it over 40. Simplifying the numerator, 25y minus 24y gives me simply y over 40. Okay, part D, x plus 3 over 3 plus 2x over 5. So here you need to be careful. Very often what students do, they cancel the 3 in the numerator with the 3 in the denominator. You cannot cancel these two. Okay, if you cancel, you need to cancel for x as well. So here the LCM is 15. Now 15 divided by 3 gives me 5. 5 times the numerator of the first term, which is x plus 3, plus 15 divided by 5, 3. 3 times the numerator of the second term, which is 2x. Now I need to expand the first bracket. So 5 times x, 5x, plus 5 times 3, 15, plus 3 times 2x, which is 6x, the whole of it over 15. Simplifying, that is, we add the like terms. 5x plus 6x gives me 11x plus 15 over 15. Again, you need to be careful. When you're simplifying, you need to add the like terms. Here, I cannot write 26x. 11x and 15 are not like terms. So, the answer is going to be 11x plus 15 over 15. Part E, m minus 3 over 6 plus 3m minus 2 over 8. Now the LCM of 6 and 8 is 24. So 24 divided by 6 will give me 4. 4 times the numerator, which is m minus 3, plus 24 divided by 8, 3. 3 times the numerator of the second term, that is 3m minus 2. Simplifying, expanding the brackets, will give me 4m minus 12 plus 9m minus 6, the whole of it over 24. Now again I add the like terms. 4m plus 9m, 13m, minus 12 minus 6, which gives me minus 18 over 24. Next example. Here I have a minus between the two terms, so I need to be careful of the minus sign. The LCM of 5 and 2 is 10. 10 divided by 5, 2. So 2 times the numerator, that is 2b plus 3, minus 10 divided by 2, 5, times the numerator, that is b minus 2. Now expanding the brackets will give me 2 times 2b, 4b, 2 times plus 3 plus 6. Now minus 5 times b minus 5b. So here be careful, minus 5 times minus 2, which gives us plus 10. Over the LCM was 10, so over 10. Now adding the like terms, I'll have 4b minus 5b and 6 plus 10, which gives me minus b plus 16 over 10. Now we move on to algebraic denominators. So 3 over 2a plus 4 over 5a. The LCM will give me 10a. So 10a divided by 2a gives 5. 5 times 3 plus 10a divided by 5a, 2. 2 times 4, which gives me 15 plus 8 over 10a. That is 23 over 10a. Part B. 5 over 6x minus 7 over 4x. The LCM is 12x. 12x over 6x will give me 2. 2 times 5 minus 12x divided by 4x, 3. 3 times 7. So we have 2 times 5 minus 3 times 7. When simplifying, we get 10 minus 21 over 12x, which gives minus 11 over 12x. Part C. 5 over 9y plus 3 over 7. So here the LCM will be 63y. Now 63y over 9y. So we have the workings on the right hand side. You can see that 9 will cancel with 63 to give me 7, and y will cancel out. So I'm left with 7. 7 times 5 plus, now 63y divided by 7. I divide by 7, I get 9, and we have also the y which is left. So plus 9y times 3, which gives me 35 plus 27y over 63y. We now move on to multiplication of algebraic terms. So part A, 2mn over 7 times 14m over n. So we're going to write it in expanded form. 2 times m times n times 14 times m over 7 times n. Simplifying, we can see that n will cancel with n, 7 will cancel with 14, giving us 2. So now in the numerator we have 2 times m times 2 times m, which gives us 4m square. In the denominator, nothing was left, that is 1. So we have 4m square over 1, which is 4m square. Now this 14, I kept it as 14, and we have cancelled 7 into 14. We could have written 14 in terms of its prime factors. Part B, 8a cube b over 15c times 5ab square over 24a square c. So writing it in expanded form, which gives us a square b to the power of 3. In the denominator, we have 3 times c times 3 times c, which gives us 9c square. So the answer is a square b cube over 9c square. We now move on to the next part, but this time, instead of writing in expanded form as we did for the previous two parts, we are going to use the laws of indices. So, if you remember, in grade 7, we had learned about the laws of indices. The first one is the multiplication law, that is a to the power of m times a to the power of n will give me a to the power of m plus n. And the division law gives me a power m divided by a power n, which is a to the power of m minus n. So we are going to use these two laws now to simplify. Part A, 6x power 4 y over 7z times 14xy square over 3x square z. So I have kept all the numbers together, 6 times 14. I have grouped the 2x together, x power 4 times x. So using multiplication law, I have x to the power of 4 plus 1. The 2y, y times y square, I have written it as y to the power of 1 plus 2. The whole of it divided by 7 times 3 times x square. Z, I have z here and z here. So it's going to be z to the power of 1 plus 1. Simplifying, I get x to the power of 5, y to the power of 3 over z to the power of 2. I have added the powers. So now we cancel some terms. 3 will cancel into 6, giving me 2. 7 cancels with 14, 2. So I have 4. Now you can see that we have x in the numerator and x in the denominator. So we are going to apply the division law here. I will have x to the power of 5 minus 2 y cube over z square, giving me 4 x to the power of 3 y to the power of 3 over z power 2. Now I could have simplified all of them at the same time. That is, instead of doing it in two steps, multiplication law then division law, I could have done both at the same time. Part B, 12a power 3 b power 4 over 5x power 2 y times 25x cube y cube over 6a b square. So here again we are going to use the laws of indices. Now 5 will cancel with 25, giving me 5. 6 will cancel with 12, giving me 2. So 2 times 5, 10. Now I'm going to group the like terms. So a cube divided by a, giving me a to the power of 3 minus 1. B power 4 over b power 2 will give me b to the power of 4 minus 2. X cube here divided by x square will give me x to the power of 3 minus 2. Y cube over y will give me y to the power of 3 minus 1. Simplifying will give me 10 a square b square x to the power of 1 y to the power of 2. I could also omit the power 1 for x. I can just write it as x. Now we move on to division of algebraic terms. So let us look at some examples. Part A, 5x over 4 divided by 15y over 2. So remember, when we have a division, we need to multiply by its reciprocal. So we have 5x over 4 times the reciprocal, which is 2 over 15y. Cancelling the terms, I have 5 which will cancel with 15, giving me 3. 2 cancels with 4, giving me 2. So in the numerator, I have x. In the denominator, I have 2 times 3y. So The answer is x over 6y. Part B, 8x squared y over 5 divided by 2xy squared over 25. Again, I have to multiply by the reciprocal of the second term. So 8x squared y over 5 times 25 over 2xy squared. So writing it in expanded form first, and then we cancel 5 with 25, giving me 5. 2 will cancel with 8, giving me 4. X cancels with x, and y cancels with y. So in the numerator, I have 4 times x times 5, and in the denominator, I'm left with y. So this gives me 20x over y. Now we move on to some more examples, but this time we are going to use the laws of indices. So 2m power 3 n power 4 divided by 5p divided by 6m n squared over 25 m squared p power 5. So division means multiplication by the reciprocal. So we have 2m cubed n power 4 over 5p times 25 m squared p power 5 over 6m n squared. So I have the numbers first, 2 times 25. Now m, we will have m to the power of 3 times m power 2, giving us m to the power of 3 plus 2. So I have applied the multiplication laws of indices. N power 4, p power 5. In the denominator, I will have 5 times 6 times m times n squared times p. Simplifying, I'll have 5 m to the power of 5, n power 4, p power 5 over 3 m power 1, n power 2, p. So now I apply division law for m, base m. I'm going to have 5 m to the power of 5 minus 1, n to the power of 4 minus 2, because we also have n to the power of 2 in the denominator. Same for p, p to the power of 5 minus 1 over 3. So the answer is 5 m to the power of 4, n to the power of 2, p to the power of 4 over 3. A second example using laws of indices, x to the power of 6, y to the power of 8 over p power 3, q power 4 divided by 2x cubed y power 6 over p power 7, q power 6. So again, we need to multiply by the reciprocal of a second term. Now, grouping the terms, simplifying, I get half x cubed y squared p power 4 q squared. So here are some exercises for you to practice on multiplication and division of algebraic fractions. You also have some exercises on addition and subtraction of algebraic fractions. You also have some links where you can get some additional practice on LCM of algebraic terms and algebraic fractions. So students, we have reached the end of this revision video on LCM of algebraic terms and algebraic fractions. I would advise you to practice the questions found in your textbook as well as the questions found on the previous video on this chapter. Practice makes perfect. So please practice the different questions, as this is a topic where students usually make mistakes. I hope you have enjoyed this video. Until next time, it's goodbye.